If you clicked on this video, you probably are asking yourself what Docker actually is and how it integrates into an IT landscape. My name is Anthony, and I'm going to go over a few things that'll give you peace of mind when learning and utilizing Docker in your actual workflows. We're going to go over what Docker actually is, the installation, the correct tooling that you'll actually need, building an image with a Dockerfile, running that container, and also debugging a few of the things that might happen when you're first starting off utilizing Docker. So what is Docker and why is it so useful? Long story short, Docker is a way to package some sort of software to ensure that it runs on any type of hardware. So let me clarify on that. Think a software developer is developing an application that has a lot of dependencies on that machine. Well, if you move that application to another machine where those dependencies aren't present, then that application won't run and won't be able to be used properly. So this is where Docker comes in. It ensures that all the dependencies are present within that container image so that that application can run properly every time, regardless of what hardware that container is on. So now that we know what Docker is and why it's used, let's look at trying to install it and what tools we will need in order for that to happen. The one main prerequisite will be that virtualization needs to be enabled on your Windows machine. So if you do not have that enabled, or if you don't know how to check, let's look at that now. So if you want to figure out if your machine has virtualization enabled, let's go to Task Manager, open that up, and then click Performance. On the CPU tab, you'll see virtualization here, and it will either say enabled or disabled. My CPU has it enabled, and there are some CPUs that don't allow enablement of virtualization along with the actual motherboard itself. So first of all, make sure that your motherboard and CPU can support virtualization. And if this is disabled, you will have to go into your motherboard's BIOS and enable it somewhere in there. If you do not know where it is, YouTube will be your best friend for this. You can search up your specific CPU or motherboard combination, and you'll be able to figure out what BIOS is associated with that. So in order to figure this out and for have Docker to work properly, you will have to have this enabled. So now that you know that virtualization is enabled on your machine, we can now go to Docker's website and download Docker Desktop. So all you need to do is go to docker.com, click here, and then you can download Docker Desktop. Depending on what your CPU is, you'll be able to click AMD 64, ARM 64, Apple Silicon, or Intel chip. Look at what your CPU is within the Task Manager, copy that, and figure out what infrastructure that CPU is, and then download this accordingly. For me, since I have an AMD Ryzen CPU, I am going to download for Windows AMD 64. Now, once that's downloaded, we can click this, bring up that, click yes, and now it is initializing and configuring. So add that to shortcut, unpack the files, and then we should be all set and ready to go. If everything works right and is successful, you should be able to launch Docker Desktop like I have here, and everything should be in working order. If you do have any issues, comment down below what issues you're experiencing, and I'll be happy to help with those. I have had some issues with Windows Subsystem for Linux that's given me some issues, so maybe I can help out and provide you some clarification on that. Now that Docker is installed, we should be able to start looking at building a Dockerfile and actually building an image. So let's get started on that. So now that Docker is running on your machine and everything is working as intended, we can start to look at building a Dockerfile along with the other code that will be packaged on this container image. As you can see here, we have a plethora of different statements on this Dockerfile along with a Python script that handles an HTTP connections on port 80. What this Dockerfile will do is in the current directory, based upon the parameters that we give the Docker command, it will package this Python script within that container image. So with this here, we have a few different statements. We have from, we have work dir, we have copy, we have expose, we have env, and we have cmd. All of these statements do different things in order to package and build this Docker image properly. So as you can see here, we have a Python file. This handles, as I said, HTTP connections on the port that we're giving it, which is port 8080. But what if that machine doesn't have Python installed? That's where the Dockerfile and the magic of Docker comes in. So as you can see here, we have the from command called Python, and then it gives it a little 3.9-slim. This is referencing a Python runtime image that is on a public repository that we can pull from. So that handles our Python runtime. If we were trying to run this script on a blank Windows machine, we would have to, one, install Python, two, make sure that it runs properly, and then we would be able to run this simple HTTP server script on that Windows machine. But that's where Docker comes in, and we get to extract a container image, a base image, as I said, to have Python run properly on that container. And then afterwards, we can set a few different other things to make sure that this works properly. So we have a working directory here called workdir. We'll set the working directory in the container. This is basically doing a CD and then the specific app. If you wanted to create a directory on a Linux machine, you would do make dir app, and then you would CD into that /app. But this is basically doing that same exact thing, but in one line. So we copy this into the current directory, which is in the /app directory. If you know Linux, this is essentially looking at the current directory. We would do pwd. We would be in that app directory on that container image. And then we're simply doing a CP of that file into the current directory of that container image. Afterwards, the expose 8080, that goes into the networking aspect of that Docker image and exposes 8080 to the outside world so that it can be contacted within that port. And then another kind of critical environment value is called env. If you were to look on a Linux machine and do print env, this is essentially setting an environment variable using export. So this is a pretty cool tool because, like I see here, you can get a key value and then some sort of string or an integer or whatnot. In a lot of CI, CD, and DevOps engineering models, you would have possibly some secret that gets piped in through Azure DevOps or some other secret management solution that would pipe in a secret that we wouldn't have it in plain text. So that's something that's interesting there as well. And then lastly, we would do a CMD, and then this is essentially going into the bash shell and doing Python and then running that simple HTTP server.py Python script. So all of these things make up a sort of a list of instructions that the Docker image will then be created upon. Now that we've built a Dockerfile, we can now use that to build a container image based upon those instructions. So the first thing you need to do is open up a PowerShell or a CMD. And what we are going to do is test that we can build this properly. So if you put in Docker and everything's working as intended, we have Docker engine here, it's running, everything's all good and fine and dandy, we can now build our Docker container. So with that being said, if we do Docker build /t is a flag in order to give that image a name. If we do simple HTTP _server and we do dot, it will now look at the current directory that we're in for that Docker file and read in those instructions that we gave it here. I did have to change the environment name to random string and then a string of numbers because it was complaining that this was a key or secret. So in your specific workflow, you might have some sort of issue with that, but just for clarification, I had to change this. So if we run that and we do enter, it will now build that and it's all done. So now that you've built your Docker image, we can now view that within Docker Desktop. If we go to images and then we see here, we have our simple HTTP server image name. If we click here, we can kind of see all the layers of those instructions that we gave it, as well as some more here. As you can see, there are a few extra instructions that we did not give it specifically, but technically we did. When we do this from command, we are referencing another container image that has other instructions in order to make this work properly with Python. So as you can see, we did from Python. It is doing a few of these instructions before we actually get to the instructions that we showcased here with working directory, copy, expose, and etc. Now that you know all these things, let's go and run this container image and showcase all of our hard work. So if we go here to PowerShell, we do Docker run, and we need a -p here because we're on a local machine. I'll explain that later. We need to map port 8080 on our local machine to port 8080 on our container. Think of a container as its own specific ecosystem that has port rules. As we did in the Docker file, we exposed port 8080 so it receives requests on that. However, our specific machine doesn't know about those ports specifically. So what we need to do with this -p flag is to map port 8080 on our local machine to 8080 on the container machine so we can send and receive HTTP requests within that port. So now that we mapped port 8080 together, we now have to just give it the name of the container image so it can run properly. And if we don't see any errors here, we can do that. If we go to a Google Chrome or any of your web browsers, if we do localhost 8080, we now see that we are receiving HTTP requests. And if you didn't put the process in the background, you can actually see some HTTP requests. If we click that, we'll just move this to make it a little more pretty. If we see that and we click here, we'll see, some like requests here. So if we refresh, get a 304, refresh again, do that, click it again, we'll see some HTTP requests on here as logging. And then if we want to actually view the container on here, it'll give it a random name if we didn't specify. And we can see that the port is being mapped to 8080 and everything. So that is from front to back kind of what Docker is. And we can definitely be more complicated with this system, but that's kind of the most simple way to learn Docker is to do it. So that is all I have. Thank you very much for watching the video. If you have more time, I would greatly appreciate if you click my Git Basics video here. It goes over, like it says, all the basics of Git and gives you a comprehensive understanding of all the tools and commands that Git uses on a day-to-day workflow. Thank you very much, and I hope you have a great rest of your day. See you later.